So in the previous video, we saw how we converted the mat A, that is the given vectors, into orthonormal vectors. So you had orthonormal vectors. So from that orthonormal vectors, I can represent A as Q into R. So I cannot say whatever matrix I have found out Q that is equals to A. I can have that A can be developed using that orthonormal vector Q and R. And you know what is R, that is upper diagonal matrix. So you have first row represents your Q1, Q1, and columns always represents the vectors A, B, and C. So you have here in the upper diagonal. So second row you have Q2, and we have the same B, B, C, C, all these columns, and Q3. So all this becomes 0, 0, 0. You can insert 0 or leave it as blank. So already you know Q, already you have found out in the previous lesson, same Q I am using. So you have now the A, if you multiply these values, you will be getting the value of A. You can just check 1 by root 2 into root 2. If I multiply this, that is first vector, that is this vector, first column, first element will be, I'll have to multiply with this column. 1 by root 2 into root 2, that becomes 1, and 1 by root 2, 0, 0. So this is first value is 1, and next is second column. If I'm multiplying first row multiplying with the second column, this column, what will be the second value? 1 by root 2 into 1 by root 2, that is 1, 1 plus here 1 by root 2 into 1 by root 2, that is 1 by 2 plus 1 by 2. I will be getting it as 1, right? And this the third, what I will be getting? It will become 1, and here it is root 2, and this is also becomes 1, 1 plus 1, and this becomes 0, 2. You can just check the values here in the, I have just done only first row. So this is your actual A, B, and C. So just check your values 1, 1, 2. Here first row of your A, you can see first row 1, 1, and 2. So from A, from this vector you had your Q, and to get back your A, you have A equals to Q into R. So only we are writing the A can be factorized into Q into R, right? So you verified your first row. So second row, third row also you can verify from the factorization. Clear? So we'll do some more problems. So some of the, here you have project B. So the values of B are this onto the orthonormal vectors. So you have to have this projection of B onto the orthonormal vectors. So A1 is this and A2 is this, and then find its projection P onto the plane of A1, A2. You can see the A1 and A2. Look at the A1 and A2. Are they the columns of A or the columns of Q? So they are the columns of orthonormal vectors. So Q, this is A1 and A2 are orthonormal vectors. So automatically you can even check that. So if I add the square of this, it becomes what? If I am just checking 4 by 3, 4 by 9, right? Next the 4 by 9 and becomes 1 by 9. Just check the square root of this. It becomes 9 by 9, 1, square root of 1. So length is equals to 1. And if I multiply this with the transpose of this, or the transpose of this with this, so 2 by 3 into 1 minus 1 by 3 gives you what? Minus 2 by 3, 3, 9, and plus 2 is 4, 4 by 9, right? And next is minus 1 by 3 into 2 by 3, this value. So it gives you what? Minus 2 by 9. So minus 2 by 9 minus 2 by 9 is equals to 4 by 9, that equals to 0. So they are the columns of orthonormal. Here A is not given, directly Q values are given, right? And then find its projection P onto the plane of A1 and A2. So just make use of the formula and then do the calculation. Very easy. So you know that projection of B onto A1 is this one A1 transpose B into A1. So you have A1 transpose, because always vectors we write in a column type. So when I take a transpose, this is the given vector. And B is 0, 3, 0, and A1 is your column, that is 2 by 3, 2 by 2. Just calculate, you are getting this. So this is the projection of B onto A1, and similarly you can find it for A2, and total projections you can add. So we have projection of P onto on plane A1 and A2. And plane means automatically you have to add both A1 and A2 together. So you have A1, projection of A1 and projection of A2. That is projection of B on A1 and projection of B on A2. Just add them, I will be getting this. Or you can find out by adding, you can previously do A1 plus A2, and then also you can find the projection. So you are having this is the vector, right? So this is the projection. Direct question is on. So here one more. So we are finding here least square method. So the least square method, or you can say graphical line method. Whenever I have y equal to c plus b, that is c usually being 1 plus dt. So you have it nothing but y equals to mx plus c. Right? So here the x is your c, and this is your slope b, and c being a constant of usually 1, and y being this as usually we take it as b, right? So this is a line graphical expression. You can even draw the graph, or you can just check the data, but you have to write the matrix in terms of the first column becomes your 1, and the first column becomes 1, and the number of t's you have to enter here in the second column. So just check that. When t is equals to minus 2, you have 4 this one, so m is equals to 4. That is equals to minus 2, minus 1, 1 and 2. Right? So what is the question? Find the optimal straight line, draw its graph, and write E square. So you have to find out by least square method, you have to draw the graph and also find out E square.